Okay, now let's continue to our second part. Here I'm going to formulate the two-type problem we need to discuss and solve it with complete information. So we're going to discuss this monopoly pricing problem, and we're going to use that to illustrate the ideas. So imagine that you produce and sell one product, okay? You are the only one who are able to produce and sell this product, so you are a monopolist. In this case, how would you price your product to maximize your profit? That's your monopoly pricing problem. So before we discuss the two-type problem, let's spend some more time to discuss monopoly pricing and in general why it is hard. So suppose you know your demand function, then you know how to solve this problem. Okay, we have done so for a lot of times. You know the problem will be like this: the optimal price will be 1/2, and then your profit will be 1/4. Okay, this is the case when you have a demand function, and actually, we know the demand function is actually coming from the fact that, or the assumption that, consumers' valuation or willingness to pay lie uniformly within 0 and 1. Okay, one consumer wants to actually only one consumer. Okay, normalized to 1, and the willingness to pay is between 0 and 1 uniformly. In this case, we are saying that the consumer's utility function is V minus P when V is his utility. V is his valuation. So if my valuation is, for example, 0.8, if the price is 1/2, I'm going to buy, and my utility will be 0.3. But if buying the product gives me a negative utility, I'm not going to do that. Okay, so with that in mind, let's visualize the producer surplus and consumer surplus. Producer surplus is how much the manufacturer earns. Okay, so that's his profit, and the consumer surplus is the utility of all the consumers after the trading is done. Okay, so some consumer earns a positive utility, and some consumer, if they do not buy, the utility is 0. Okay, so to visualize this, we know we're going to have the quantity here, price here, and this is the demand function, inverse demand function. Okay, you're going to charge 1/2 as your price, like this, and essentially that tells you that the number of consumer that is going to buy is 1/2. Okay, only for those consumers whose valuation is so high, whose valuation is higher than 1/2, that they were going to buy. Okay, these consumer will buy and these consumer will not, because their valuation is lower than 1/2. Okay, so this part is your producer surplus. For each consumer here, you earn 1/2. So the area here is your total profit, 1/4. And for consumers, their surplus is here. Okay, for a consumer with this valuation, he is going to earn this amount as his surplus, and in total, this is the total consumer surplus. And the social welfare is the producer surplus plus consumer surplus, and in total is this area, 3/4. So that's what you did. And now suppose here comes a critic, and he come into your store and ask you some questions. So he say, some people are willing to pay more, but your price is too low. Indeed, that's true. And also, some potential sales are lost because your price is too high. So he is arguing that your pricing strategy is not good. Here is his suggestion. Who told you that you may only set one price? Okay, what you should do is to ask each consumer how much they are willing to pay. Okay, and then charge them accordingly. So he means there comes a consumer, ask him how much he wants to pay. If you say X, then charge X to this consumer. So now, as smart as you, does that work? So certainly your answer would be no, because who's going to tell you his valuation, right? Here we say price discrimination is impossible if the consumer's valuations are completely hidden to you. Here, price discrimination is a specific term used in economics and marketing, but somehow that just means charge different consumers different prices, okay, and typically according to their valuation. Here, this is impossible because no one is going to tell you that they really like this product. All of them will tell you the product is so bad, so ugly, so useless, and I only want to pay $0. That's why price discrimination does not work. That's why information asymmetry creates some problems to you. And if you can see the valuation, you're going to charge each consumer his valuation, as we mentioned, right? And this is perfect price discrimination. In this case, you can earn the most money that's possible. So let's visualize the consumer and producer surpluses under perfect price discrimination. So let me very quickly visualize what we did when there is no price discrimination. In this case, this is the producer surplus, and this is the consumer surplus. Consumer. Now, for each coming consumer, you're going to charge him exactly what he values his product. Okay? So that means your producer surplus will be exactly everything in this triangle, and no consumer is going to earn anything. Okay? So this is the best you may have. You can extract all the surplus from consumers, and this is the worst situation for consumers because they can earn nothing by buying or not buying your product. Okay? However, we say information asymmetry causes inefficiency and reduces social welfare. Okay? Social welfare is the sum of consumer and producer surpluses. So if you still have that graph on your screen or on your handout, when there is a perfect price discrimination, the social surplus is the whole triangle. But when there is information asymmetry, when the producer does not implement price discrimination, social surplus is just here. Okay? So we say information asymmetry causes inefficiency. What's more interesting is that here we have decentralization, and decentralization itself does not necessarily cause inefficiency. Okay? If there is no information asymmetry, if the producer uses perfect price discrimination, then social welfare is maximized. There is no inefficiency. Here, only information asymmetry introduces this inefficiency. Okay, so in general, no consumer will tell you how they like this product. Okay, otherwise his surplus is going to be zero. So as a producer, what you may do in practice is to test or to guess a consumer's valuation according to some specific attributes or characteristics. Okay, one most common practice is, for example, to charge different prices according to different occupations or ages. Okay. For students, typically the fees for some events, movies, baseball games, or something. For students, typically the fee is the lowest. And then for adults, they need to pay the full fare. And then there are typically some discounts for seniors. Okay? So now you know why producers, why sellers are doing this. They are not trying to be nice to students. Okay? They do this because they know typically students are willing to pay not so much, and to extract surplus from students, they need to lower the price for students. Adults are willing to pay more, and that's why adults are charged a higher price, and the same thing happens to seniors. Another very interesting example is regarding this Orbitz.com. This is a traveling traveling information website in the United States. You may go to this website and search for airline tickets, hotels, and or car rental, and so on. The fact is that this website found that if a consumer uses Mac to connect to their website, these consumers, one type of consumer use Mac, the other type of consumer use, for example, PC, and they found that the first group, those use PC, those using Mac, tends to spend more on their websites. Somehow that means if you are using Mac, typically that means you have more money, okay? Or only those guys who have more money buy Macs. So they use this practice. If you search for hotels in the same region at the same night with the same functions you need, Orbitz.com is going to suggest some more expensive hotels if you are using Mac, but they will select cheaper hotels to PC users. Okay? And exactly again, that's because they believe Mac users are richer. Okay, so sellers are guessing how much one is willing to pay. They are not trying to be nice to students, and if you do not believe that, at least you agree they are not trying to be nice to PC users. Okay? If you are interested, you may want to read this particular article on the Wall Street Journal. Okay, so let's start our analysis with the two-type model. We're going to consider the easiest case with valuation heterogeneity. Okay, heterogeneity just means difference. So we're going to assume there are two kinds of consumers. For each kind of consumers, if they get Q units of the product by paying T as the total payment, the utility is going to be a function of QT and theta. Here, theta means some kind of valuation, and the total utility is theta times V of Q minus T. So V is a function that measures how your marginal utility decreases when you get more products. Okay, so we assume P is increasing but concave. It would be a function like this, so that when you get one product is good, two products is still good, and 5 to 6 is okay. But if you have 100 and it goes to 101, it's almost valueless. Okay, so that's why your V is generally increasing and concave. Reasonable assumption. So once you have this utility, it is multiplied by a type theta. Theta means some kind of valuation and is a consumer's private information. Here we assume theta is either low or high. Okay, we don't know the value, but we know one is lower than the other. And some consumers have a low valuation for this product. Some consumers are willing to pay more. Okay, T is a price or the transfer from consumer to the producer. So no consumer wants to pay a lot. So that's why for each dollar you pay, there is a 1 unit of utility loss. In this case, we say a consumer having theta H as their theta's value is a high type or type H consumer, and similarly low type or type L consumer's theta is theta L. The seller somehow believes or estimates that beta is the probability for one guy to be a low type, and 1 minus beta is the probability for one guy to be a high type. Or you may imagine there are 1,000 potential consumers, and beta is a proportion of low type consumers. Some more settings. Unit production cost is C, and we assume C is less than theta L, so that you are willing to do business with either type of consumers. For manufacturer or the seller, by selling Q units and getting T, the seller earns T minus CQ. Okay, the seller gets this amount of money by paying this amount of cost for production. So now if you are the seller, how would you price your product to maximize your expected profits? Okay, in general or in reality, there is private information. You cannot tell whether theta is theta L or theta H. In some sense, theta is a random variable to you. But now let's first discuss what if we can see the type, what if we have complete information. So when there is complete information, under complete information, the seller can see the consumer's type. And if I know the consumer is of type H, I'm going to solve this problem. I need to decide a quantity to sell and a price to charge. Okay? With this, I can earn TH minus CQH. And the only thing I need to make sure is that I need to make sure the consumer is going to buy, or the consumer is going to accept my offer. Okay? In that means the consumer's utility must be non-negative. Okay? As long as it's non-negative, the consumer is going to accept my contract or my offer. So to solve this problem, okay, note that the constraint must be binding at any optimal solution. Binding just means it will become an equality. Okay? So why this is the case? I'm a seller. I want the price to be as high as possible. The only reason that I cannot do that is because if the price is too high, the consumers will not buy. Okay? So if I can still do that, I will keep increasing the price until this guy becomes an equality. Okay? If I can make sure, if I'm sure the consumer's type is theta H, then I can do this. I can always increase I can always increase TH until this is an equality. So if this is not, I will keep increasing TH. And that's why an optimal solution satisfies this equality. And then the problem can be reduced to a single dimensional problem because TH somehow must be QH times VQH. So we replace TH by this, and then this becomes a single dimensional problem. First order condition, we know the optimal quantity QH tilde will be satisfying this first order condition. And then the optimal transfer will be decided according to this equation, like this. So the same thing will happen to a type L consumer. So no matter what's the consumer's type, the first best solution will satisfy the equations we just mentioned, the first order condition for quantity, and then the binding constraint for transfer or for payments. We define a term rent to be the consumer's surplus of trading, or how much the consumer earned in this trading. And under complete information, in any case, the consumer can earn nothing. Okay? The seller can extract all the surplus or all the rents from the consumer because the seller really sees the consumer's type. Okay? So now, through all kinds of discussions, we can see if the seller can make the contract offer and can observe the agent's type, then the seller can get everything. And that means private information is really the thing that protecting an agent or protecting a consumer. So that's the end of the complete information case. Next, we will introduce the optimal pricing plan under information asymmetry, and then try to do some comparisons and draw our conclusions.